Alright, starting lesson 2.5, finding rational zeros. Alright, how do you do that? Okay, when you're working with some crazy polynomial and you're trying to find the zeros and factoring methods don't work, then what do you do if working things out by hand? Alright, well, what you're going to do is find factors of the constant over factors of the leading coefficient. Alright, and then there's different types of tests you could do. You could evaluate algebraically using synthetic division, or you can just go to your TI calculator and use the trace function. Alright, I'll show you how to do all of these. Alright, let's go to one example here. This lesson consists of one example, and all you need to do is understand this one example to do all the problems in the lesson. So example 1, find all the rational zeros of the function. Now looking at this function, we can't factor the expression. Okay, what do you do then? All right, well, step 1 is to find factors of the constant. What are factors of the constant? All right, well, this is the constant. Oh, sorry, that's not the constant. Here's the constant, -9. What are factors of it? Well, 1 goes into 9, 3 goes into 9, and 9 goes into 9. All right, and you're also not just going to look at the positive factors, you're going to look at the negative factors as well for all of them. All right, then it's over factors of the leading coefficient, whatever's in front. All right, so what are factors of 3? 1 and 3. And once again, we're looking at the positive and negative factors of that. All right, now, based off of the information that we have here, there are many different possibilities. What are all the possibilities? That's the first thing we need to understand. All right, well, we divide 1 into 1, 1 into 3, 1 into 9. So 1 is a possibility, -1 is a possibility, 3 is a possibility, -3 is a possibility, 9 is a possibility, -9 is a possibility. All right, now I'm going to divide 3 into the 3 numerators. 1/3 is a possibility, -1/3. Oops. -1/3 is a possibility. All right, and I divide 3 into 3, I get 1. That's just repeating what I have here. I divide 3 into 9, that's just repeating what I have here. All right, so here are all my possibilities. Now, these aren't solutions, these are possibilities. Okay, what do you do next? Option 1. You can just evaluate the function using these possibilities. So I'm going to test out 1. I'm going to plug it into the function. So I have 3 times 1 to the 3rd power minus 19 times 1 squared plus 33 times 1 minus 9. All right, if I work all that out, I end up with 8. Now, what does that mean? That means that 1 is not a 0 for the function. All right? In order for it to be a 0 of the function, the result at the end has to be 0, which is not the case here. You can also use synthetic division. All right, here's 1. And we use the coefficients for the polynomial. All right, so I bring down the 3, multiply, then add. Multiply, then add. Multiply, then add. Okay, once again, my remainder is 8. If the remainder was 0, then it would be a solution. In this case, it's not. It's not a 0. Okay, so what do you do next? There's option 3. You have the trace function on your calculator. And so with the calculator, you don't really have to do any of this. All right, you just figure out on your calculator based on the TI tutorials I have available. You graph the function and you use the trace function on it, and you can locate the zeros. All right. Now here's the general idea. All right, here are my factors, if those are the zeros. All right, but these factors have a multiplicity of what? Now, if you look at your function, it looks something like this, right? All right, that's 1/3, and that's 3. All right, so the graph passes through this point, which means it has a odd multiplicity, and it touches this point and bounces off, which means it has an even multiplicity. So since my degree is 3 for this polynomial, since this has an even multiplicity, I must see this factor twice when factoring, and since this has passed through only one point here, passing through the x-axis, it must have an odd multiplicity, and both of these add up to 3 together, which is what you need. Alright, so that's how you just come up with the general function that has those zeros. Alright, and that's all there is to this lesson. Alright, now you need to know how to do this by hand, and on the benchmark, no calculators are allowed. Alright, so once again, just touching on the big idea, factors of the constant or factors of the leading coefficient. You figure out all the different possibilities, and then you test them one by one. Alright, now we're going to learn some strategies later of how when you figure out one zero, alright, everything just becomes so much easier after you figure out one zero, and you'll be able to figure out many more zeros typically after you figure out the first one using some other methods. But we'll get to that. Alright, if you have any questions, please make sure to ask. Begin the assignment at the bottom of the webpage.